2D animated image morphing is a really good visual effect, and I've written a Windows desktop app in C++ to allow the user to create 2D animated image morphing projects. A project can be created, saved, loaded, exported as an animated GIF. And briefly, the process involves selecting a source image, in this case David Banner, selecting a destination image, the Hulk, and then you go through an image and create feature points. These are positions that you think are particularly important in that image. When you're dealing with faces, it will be things like hairlines, eyes, nose, mouth, chins, ears, etc. So you can create a feature point by a single click. That will create a point feature, or you can do a freehand drag around the face or around a wheel or something like that. And that will create a path feature. That path will be sampled 25 times to create 25 feature points. The freehand path creation is really just a shortcut to give you 25 feature points. But this is an example of a project that hasn't used a freehand path. I've just gone around and clicked in various places in the source image, and then gone around the same number of places in the destination image and created feature points for the equivalent in the source. So say for instance the top of the nose there, I would have clicked there in the source banner image, clicked there in the destination Hulk image, and then I would have pressed the link button, and that links the two features together. You can see here these are all the linked features. Once you have a set of linked features, you can effectively triangulate the source, which I'll go into a bit more detail later on, and then create the equivalent triangles in the destination, and then lerp between the two, and render the lerped triangles. In this case, I've called it the lerp window. On the right hand side here, you can see this is the result of the lerp render. So if we go slowly from one to the other, we can see what's going on. If we click the render triangles button, we can actually see what's happening in terms of the triangles as well. So a brief explanation of what to do. Load a source image, load a destination image, create a set of features in the source, either by clicking or freehand dragging, and then create the equivalent features in the destination image, link the two features together to give you a set of linked features. Once you've done that, you can then start triangulating and lerping between the two sets of triangles to create an animated morph. This is a pre-built project that I've created, the Hulk. There is another one. I created another. This is another point-based morph. So I created the source of the ZX Spectrum, destination Commodore 64, and then some key points around basically the edge of the computers, just the cases really, the edge of the cases, and I also linked up the keys on the top row, the keys on the bottom row, and that gave us a set of linked features that we could morph between to give you this effect. That's quite a nice effect. And the last pre-built project that I created was a car. So I created the source, a Sierra Cosworth, the destination, an Escort Cosworth. And this is an example of freehand drawing. So I've freehand drawn around the wheels and the driver's door, the driver's window, the window behind the driver, the sort of passenger's quarter window thing, and the front windscreen and the 2 headlights, and then drawn around the equivalent in the Escort Cosworth, linked the 2 together, so we can see here they're the linked features. If we click render the samples, we can see effectively the freehand drawing has been sampled 25 times. Each freehand path has been sampled 25 times to give a shortcut effectively to create 25 feature points. And now we can lerp between those 2. So we go from the Sierra Cosworth to the Escort Cosworth. And that's another nice effect there. So if we go into a bit more detail about the UI, what do we have? Well, we have a source image button that lets you choose a source for the morph. A destination image button lets you choose a destination. Then the splitter window here that can be moved around. And the splitter window has a left side, which is the source pane, and a right side, which is the destination pane. Below that, we've got the selection combos, which tell you what's currently selected. If I select the door, for instance, there, we can see that that is feature 0. If I select the door there, we can see that is feature 0. Okay. Below the selection combos, we have a toolbar, so we can create a new project like that. We can open a project, so that's the Cosworth. We can save a project, and then we have the 2 tools. One is the select tool. Each pane, the source image pane has a selection, and the destination image pane has a selection. The 2 are independent. So say, for instance, I've drawn a freehand path around the driver's side headlamp, and I've also drawn the equivalent in the Sierra Cosworth image, and then I want to link the 2. I would select those 2 and press the link button. As you can see with the green line, that's already been done by myself before this. So what's in the toolbar? We have yeah, sorry, I've already gone through this, but project new, project open, project save, select feature tool, create feature tool. That lets you do a single click or a freehand path drag. Then we have effectively image extents feature points. This button here gives you 4 free feature points, which are the extents of the image. If I click there, we can see the points that are used to triangulate, and you can see I've got 4 free ones that are the extents of the image. If you haven't got that, then the only thing that will be used to triangulate is the feature points that I've personally created. So if we take that off, for instance, we can see on the lerp frame over here that the rest of the image is ignored, because it's only when I'm rendering the lerped image, I render the contents of the triangulated points. So let's turn that back on. Then after that, we have the link button. So again, we've explained that you select features, link them together, or press them again to unlink them. And then we've got delete feature, which will allow you to delete a feature. If it's linked, then that link is broken. And then we've got delete all features. Delete all features is kind of like project new, but it doesn't get rid of the images, it just gets rid of the features. Then we've got some rendering options. We've got the render the freehand path. If I just turn that off, we can see. So these are the freehand paths that I've drawn, and we can turn that on or off. And then we've got render the sampled positions along freehand paths, and then we've got render links between features, and then we've got render the triangulation. So turn those off. The next button shows or hides the Lerp window. So normally I just have that open because it's nice to see how the morph is progressing. Have I chosen the right set of features? Do they give a good smooth result? And then once you're happy with that, we've got export to GIF. You choose the file name of the GIF that you want to export to. You choose the width and the height of the GIF. You choose the number of frames. Obviously, the higher the number of frames, the smoother the animation. You choose the frames per second for the animation, and you choose whether to bounce or not. I always tend to have bounce on because I like to, if I demonstrate what bounce does using the Lerp slider, instead of the animation just going from the beginning to the end like that, the animated GIF would actually go from the beginning to the end and then back to the beginning, which is, I like that effect, so I tend to have that on all the time. And then once you're happy with all the results, you press OK, you watch the progress, give you some feedback, and once that's done, you have your animated GIF. Okay, so more details about the actual triangulation process. So the linked features gives us two sets of points, i.e. the source points and the destination points. The set of source points are triangulated. I use Delaunay triangulation implementation in opencv. Each triangle will know the indices in the source point set that makes up its vertices. You can use those triangle vertex indices in the destination point set to create the destination triangles. So as you can see, over here on the left is the result of the Delaunay triangulation, and over here on the right is those same triangles but referencing the destination point set. So we've got two sets of triangles, source and destination, and then we can create an intermediate, a lerped point set between the source and the destination. And once we've got that, we can then create a lerped triangulation using the lerped point set. So now we've got a set of intermediate lerp position triangles to render. What do we do now? Well, we to render the source and the destination, it's just straightforward. It's a logical to device transform pixel set operation effectively. That takes into account the device space occupied by the image. I've not got zoom actually. I could put zoom in as well because that would all just be straightforward. But to render the lerp, this area over here is a little bit more involved. So I go through each lerped triangle, the extents of each lerp triangle. I test the pixel to see if it's in the triangle or not. If it's not, I do nothing. If it is, I go through. Oh, sorry. Yeah, one thing that I did forget is when I've created the source triangles through the Delaunay triangulation and the destination triangles using the triangle indices from the source, I then, for each pair of triangles, create a transform. Sorry, that's not right. Once I've created the lerped set of triangles, I've got three sets of triangles, the source, the destination, and the lerp. So I then create a pair of transforms for every lerped triangle that would take it to its equivalent source triangle and take it also to its equivalent destination triangle. So when I'm rendering a lerped triangle, I take the point, I transform it into the source, I transform it into the destination, which gives me 2 pixels. I can then blend to give you that type of effect. There are some sort of special cases, some that you have to look out for. If a position in a lerp triangle doesn't map to a source position that's valid but does to a destination, you might want to, I do something, I use the destination and vice versa. So also the project is multi-core aware, and so it's real-time, effectively real-time morphing of 2D images, real-time animated morphing. The project, like I say, is written in C++, and it's available to use, alter, and look at on GitHub. I'll put those details in the description. Yeah, so overall, it's a 2D animated image morphing sort of mini studio that allows you to select a source image, select a destination image, create a set of features, link those features, and then animate using a Lerp process between the two features. The triangulation is done using opencv's Delaunay triangulation, and I think that's about covers it. This is an additional few seconds of video to show the results of the exported GIFs, animated GIFs from the projects, the 3 projects that I've pre-built. I forgot to put that in the initial video. So if I browse to the presets folder and load up, for instance, this is the 8-bit morph between the ZX Spectrum and the Commodore 64 with bounce set on to true. As you can see, it's bouncing backwards and forwards. It's quite a nice effect. This is the Cosworth car morph between the Sierra and the Escort. Again, bounces on. Pretty cool stuff. And this is the Hulk one, from Tabana to the Hulk. Again, that's quite a nice effect. Bounce is set on there to true. So those are the results from exported GIFs from the pre-built projects that are included in the project. I also noticed in the first video that when I showed the selection combo, it was overpopulated. There was many duplicated feature entries, so I've fixed that as well. Okay.